Hi everyone, welcome back to the Keploy channel. And in this community call, we have some exciting updates. What's new with Keploy? What like how we have moved to complete zero code approach as well. So we have Charan who will be showcasing how Keploy can generate test unit test cases with the help of any LLM that you prefer or that you might use. As well as we have launched Keploy UI console and how to perform various operations from there. Next, we have Akash, who will be showcasing how you can get code coverage without installing or integrating any kind of SDK, Keploy SDK into your code. So over to you, Charan.
Yeah. Hi guys. So let me share my screen.
Yeah.
Yeah. So uh, yeah. So to the previous users or whoever contributed to Keploy might have known this that Keploy is majorly used to create and generate like end-to-end test cases majorly. So we were in end-to-end test case space more than unit test case space. So because we believed that end-to-end test case will bring more confidence in the tests which we write, but we observed that there is a gap between our users as well as Keploy. That is majorly unit test generation because the traditional method which people use to do testing is majorly from the developers is like unit tests. So people are like very a bit hesitant to come over to E2 test because they are not introduced to it. So we wanted to fill that gap by introducing this unit test generation with GenAI. So let's go through the README. So we have created this unit test generation from based on the Meta LLM research paper. So we'll be discussing that in few seconds also. So let's go to the original README. So you can see here the link for the Meta LLM paper is also given here. So majorly we had three objectives in our mind when we designed this product for unit test generation. Majorly, obviously from the name you can say that we will automate the unit test generation. And second thing is majorly improve the edge cases. So whenever someone writes unit test, majorly they would be missing the edge cases only. So we would the this generations bit will be actually generating those edge cases. So uh, and boost the coverage definitely. So whenever we tried with this product, so whoever had something like 20% of the coverage through unit tests, it was boosted to 50 to 80. It may not reach to 100 that perfection level because as you know LLM is not that perfect. So we would be reaching up to 80. So to boost someone's coverage from 20 to 80, this product would be very helpful. So this is the design of on which we actually implemented this. So this is based on Meta LLM paper. So basically we will be asked prompting the LLM regarding the test cases we need. So if there are any few test cases which are already present in the test case file, we'll be taking them and providing it to the LLM, so that once we get those data from LLM, the response from LLM, we'll be processing it, and then we will be trying to build it. So building is nothing but we'll be running the test command which is there, and then we'll be checking which test cases have actually passed and which have already failed, which have failed. So majorly we observed this because when people try to generate test cases using GitHub Copilot or anything, or ask ChatGPT or someone, they'll be getting some content. But out of 10 times, 7 to 8 times, it will be like the test case would fail. So to go and try it out and prompt the ChatGPT or GitHub Copilot many times to get that one useful test case is very tiresome. So in this process we automated that, so that whenever we prompt it to the AI, and when we get the response, we actually run the build and we check which test cases are passing and which are failing. And then there is another post process feature where we actually see if the coverage has increased or not. So if some coverage is increased, then only we keep the test, else we throw it out because it's just a duplicate test case which already the user have. So in such way, after many cleaning processes, we'll get the final test cases which are generated by AI. So those will be left out in the test case, and then we'll be getting a good coverage. So let's go through how we can use it. So the prerequisites are majorly an AI model. So currently we have many AI models like Llama, ChatGPT, and Azure. Uh, Azure LLMs. So we can use any one of them. So every LLM has its own API key, so we can get an API key from that. So right now I'm using ChatGPT API key, and once you get that API key, you need to export wherever you have your application, and then you need to install the Keploy using this command. So this is one line command which you can install in any operating system like Linux, Mac, or Windows. You can use this. So let's try it in. So let me say show you the prerequisites first. So the main prerequisite we have is currently we have is the code coverage model, like the format. So currently we only support the Covertura format of the coverage. So where there are many tools, like if you take Node, there is npm. If the Go has its own native Go tests, and Java has Maven. So like they create reports of coverage in different format. So as you already saw in the step where we calculate the coverage, so we need to read that report also. So currently we only support the only one format of the report, so that is Covertura. In future we'll be adding more. So this is the only prerequisite that someone should have to use this unit test generation. So let's now go into how to use it with an application. So I'm taking Keploy sample app, that is Express Mongoose. So let's go to the end so that we can see the generation part. Okay, so this is generation. So I have already cloned the application, and I have already had one test case, like one unit test case for this application. And let's try let's see what is the coverage currently we have. So if you can see for the routes.js, which we are trying to generate, which we will in some time will generate tests, actually have 33% of coverage. So let's now try to increase it using our tool. So this is the command you need to use to generate the unit test cases. So generally it will be like Keploy gen, that is not going to generate, and you'll be giving the source file path. Source file path is the path where we have the code of the, like the main code. So this is the main code which we have in route.js, and then you will be giving the test file path. So that is nothing but the test which you have already might have written. So that path, and because we need to prompt for these two files to the AI, so we need to give these two paths. And next comes the test command. So for the building phase, as I explained in the before design, so after we generate test, we get the response from the AI. We'll be building that test, nothing but running the test. So we'll to run the test, we need the command, because people might have designed it in a different way. So we need the test command, and at last to read the coverage report. So as a post process, so we'll be reading the coverage and seeing if the coverage has increased or not. If it is not, we'll be throwing it as it is a duplicate test case. So we need this coverage path to read whether the coverage has increased or not, and also to show whether the coverage has increased or not. So let's try this command. So as I can see, the paths are like personal path. So let me use another path which I have. So I'll be using this path. So you can see that the uh, source file path is nothing but this path, and the test file path is also this path, and the test command is just npm test, which I just ran earlier. And the coverage report path is the coverage report path where it would be generated. So let's now try how the generate works. So you can see it is getting the indentation line for the new test case to be written in this file. So it shows that the current coverage was 34, which we already know before, and it is the desired coverage should be 100. So it is now prompting to the LLM and getting back the response. Yeah, so you can see that it has got some response, and uh, what you can see is validating new generated tests one by one. So whatever tests are given by the AI, so we'll be running each of the test case for the 5 times, because we need to be sure that there is no noisy test cases or flaky test cases. So we need to run them 5 times. This is also like we got this idea from LLM meta LLM paper only. So you can see here that after running for the 5 times, we have seen that a log that generated tests passed and increased coverage. So we'll be actually you can see here the test cases are generated and they were not deleted because they were actually passed and increased the coverage. So you can see that now the after one iteration of asking ChatGPT or AI model for the test cases, it has increased up to 46. So currently the iterations are going on. So whenever we generate tests, we calculate the coverage and everything, we get the failed test. So we'll again prompt the AI that these are the failed tests, these are the past tests, and this is the coverage I got. So we prompt everything to the AI so that again it can give us the better tests according to the coverage, as well as it will see the coverage which we going to send to the backend. It will see which lines are not covered and it will generate the test according to that. So you can see now the coverage has increased to 51 after the next iteration. So you can also see that it is giving me skipped a generated test that failed to increase the coverage. So you can see that the build has passed, the it was able to run the npm test properly and no test has failed, but it has failed to increase the coverage. That means it is a duplicate test case, so we have to remove it. So that is what being done over here. So in this iteration, we actually did not get any case that is actually increasing the coverage, so it did not do anything. Then again, we will be prompting. So the iterations can be limited by a flag. So right now the limitation is for 5 iterations, so it will be running for the 5 times. So let's wait till the end how much coverage it will be able to generate. So meanwhile, we can go through the flags which are available actually. So let's go through the readme. So now you can see these are all the flags which are actually available. So those are like source file path, which you already know, test file path, which you already know. So majorly coverage format. Right now it is defaulted to Kubefera, but there can be other formats in the future. And the expected coverage. So if you don't want to target for 100, you want just 80. So it comes in very less iteration. So then you can decrease the coverage to expected coverage to 80 so that you get faster response. So max iterations, like I before said. So you can give the max iteration up to 10, 20. It's based on your wish, based on the model you are using, you can give it. And next is a test directory. You can give the test directory where the test cases should be written. And next comes the LLM base URL. So we have many LLMs out there, like I said, ChatGPT, Azure, and Llama. So you can actually provide the LLM base URL over here, and you can provide the model. Basically, right now I am using ChatGPT 4.0 only, so it's the default model, and this is the default uh, base URL. So next comes the LLM API version. So there are few LLM models like Azure where you have an API version actually. So that should be given, so then only we can prompt the LLM model. So that is also added. So these are all the flags which you can use. So let's see. So we can see that the coverage for this file, which was 33, it was now increased to 51. So this is how we actually generate boost up the coverage from 33. Now it went to 51. It's almost 20% increase in just, I guess, 1 minute or 2 minutes. So this is how the test generation works actually. So we even saw some apps going from 30 to 80 and some from 50 to 90. So getting that last 90 to 100 would be very hard because the LLM models are not that mature now. So it may be in the future. So that's why we will be continuing our work in this unit test generation piece so that we can give a proper coverage from 0 to 100. So even getting it from 0 is also a bit different, because if you have nothing in your test case file, so it will be very hard for the AI to predict what mocking you are going to use, what libraries you are going to use. So it will be good if you have at least one or two test unit tests in your unit test case file, so that the LLM can pick it from there. So that is how uh, this unit test piece is going to work. So cool. Then so this is how the unit test generation is working. So let's now see uh, about the Keploy console part. So this is basically a suggestion, or like it's a feedback from our users actually. So whenever you run Keploy tests, so you would be getting the test result, but as you can see, there will be a report created. But although we have a report created, to know which test cases have failed and what is the problem over, like let's say you got two failed test cases, to see that where are these two failed test cases, it will take you some time as you grow to create more test cases. Let's say you have 200 test cases and you have got one failed test case. So to search where that test case is failed, to see in the CLI, it will be very hard. And to even to go into the report and see where it is, that failed test case, it will be very hard in the CLI or majorly in the local. So we have designed this Keploy console, or nothing but Keploy UI. So where we can actually go and see the latest test report you have created, and also to have some operations over it, basically to actually there are many operations that we do after you run a test. So let's say you have ran a test and your test cases have failed, and let's say it was failed because you have some noisy field over there, or it may be because your application code has changed. So this is different problems have different solutions which Keploy suggests. That is, if you have a noisy field, you have to do denoising. That is nothing but mark it as a noise, so that we'll not compare it while comparing the responses. And coming to the code change, let's say you have changed the code, then the response is definitely going to change. So then we do normalization is nothing but we say that okay, the new response which we got is the correct one, so we want to replace this response with the older test case. So these are the different operations you apply when you do a test, Keploy test. So let's now see how this is going to work. So let me share my screen again.
Yep, it's visible.
Yeah. So I'm going to try it out in this application, that is Flash Mongo, which we actually you is a sample app of Keploy only. So this is a sample app, you can find it over here. And let's go to the README and see how we can do the tests. I already have pre-recorded tests over here. So I have a test set 1 and 0. So let me do a test run. So you can see that the first test set has passed completely. Okay. So let's say you have 100 test cases. So you will be at last seeing this report, right? So from this, I can never know that which test case has failed. Like from test set 1, there may be 200 test cases. I never know that which test case has failed. To see that, I have to scroll to the UI, or maybe go through the reports and see which test case has failed. So this is a bit tiresome. So we thought to create an UI to visualize these things properly and to do the operations which we were discussing earlier. So let me go through the UI. So the UI will be available here, app.keploy.io. So you can see this is the application which I just ran. That is nothing but Flash Mongo 1. And you can see the test report which I have recently ran. You can see that there are two test sets and one failed and one passed test set. So let's go into the test set to see what has been failed. So you can see here that there are two test sets, and in test set 0 we had one test set and one test case and two second test case, and then test set 1 we have one failed. As you can see, there is a red label over it, so that means it has failed. So let's now go through each of the test case, so we can even see the difference of what we can basically see the diff between the expected result and the actual result of a test case in a test run. So you can see this is the second test case, and let's see what has been gone wrong here. So you can see that what we expected was it to be a student update successful, but we the response which we got was student updated successfully. So because of this difference, this test case has failed. So we can clearly visualize key what has been changed and what, because of what uh, diff we have, this test case has failed. So let's see what operations can we do on this. So uh, so I am unable to uh, do any operations because I still did not connect it to the backend, because whatever changes I do here, it should be reflected in the local, right? So let me go and start the server. So the command is Keploy console. So you can see that the server has started, so that whatever changes we do on the UI will reflect in the local test cases also. So if you see now, I can access these operations. So majorly mark noise. So let's assume that this is a noisy field, that the body message which we will be getting is a noisy field. So let's mark it as a noise. So I'm marking it as a noise. So let me refresh. So you can see that now it is labeled as LO. LO is nothing but noise parameter. So now, as I have declared this as a noise, so it has labeled it as noise parameter. So let me see if has changed anything in my local. So I can see that one test case has been updated. So let me go and see what has been updated. So you can see here, boys.message is added as a noise parameter in the test case, which was not there before. If it was there, we would have the test case would have passed. So let's go and do some other operations. So let's say it was not a noise, and let's say it was the new response which we hard coded in the code, let's say. So now we want to normalize it, because that is the expected true value which we got as a response. So let's normalize this test case. So you can see here that we got a label that it has been normalized, and we can also see who normalized it and when it was normalized. So let's go back and see what happened. So you can see that the test case has again updated. So let's see what update has been done. So you can see that uh, the response was successful, but right now it has become successfully, because it has normalized the test case. So it has taken the new response, and appended it into the test case. So okay, let's now try some other thing. So let's now delete the test case itself. So let me do this. So you can now see that there is another label added. It says that this test case has been deleted. You can also see the timestamp and who deleted it. So let's now go and see what change has been done. So you can see that okay, the test case 1 is missing because we just deleted it. So this is how you can do different operations on a report, on based on a report, by viewing it and by seeing the difference between the diff between the response which we expected and which should be there. So we can do these operations on test sets also. So this is how we actually uh, introduce this UI, so that it will be very useful is for the users to use actually. So it is majorly to the operations which we are going to do after the test run. So yeah, so this is majorly it from me. So Animesh.
Yeah. So next we have Akash. But before we move to Akash, we have a couple of questions, Charan.
Yeah.
Yeah. So first is by Ayush. He has asked like how much token is generally consumed to increase the code coverage for the UT gen.
So actually, regarding the token, so every LLM, like right now I'm using ChatGPT. So actually, it has a particular limit to the tokens which you are going to send to the ChatGPT in one request. So I don't remember the exact number, but it has a limit. So
Mhm.
even we face this problem actually. So when we were sending the complete coverage report to AI, actually
Mhm.
we were facing this token issue, because the coverage report for a big application, let's say there is 100 file application or 200 file application, so we got a huge amount of tokens to send with the coverage report, because coverage report has every line which has covered and every line which has not covered, the number and everything. So that data to send it to the ChatGPT, it rejected it, saying that your token limit has exceeded. So we had to trim the coverage part to the particular test case only. So we were earlier sending complete test report, but then we saw it from the source file path, and we are just sending only the coverage to that source file path. So right now, for one file, uh, it will work very accurately and very good.
Mhm.
But uh, uh, considering that the command will generate test report for whole cover whole database, but we'll be sending only for that particular uh, file,
Yes.
so it will not matter much even if you have high number of lines in that one file. So I don't remember exactly the number, but yeah,
No,
I think you can
I
check.
think yeah, I think that pretty much answer like based on the context of the or the content of the test file, it will mostly depend
And
on.
also I guess there is some other also I should telling
Yeah.
that the cost
What
might be
user-
higher. Yes, yes, the cost will be higher. Yes, uh, when it comes to multiple iterations, that's why I have limited it to five iterations, and also we have limited. Right now, there's no limit to the number of test files you are going to generate. Uh,
Mhm.
let's say you have a code base, you want to generate test cases for all the files at once. You can do that still using those flags. You can do that uh, for all the files at once. But right now, even I showed the example of generating it for one test case, because I wanted to make sure that users are aware that this is going to cost uh, a bit
Yeah.
high when you use it for more files, and if there is a large code base. So that's why we are even thinking of coming up with our own LLM model, and giving it for a free user
Mhm.
subscription for some a number of tokens, for a limited number of tokens. So we are into it, so we are actually digging into it.
That, yeah. I think then Sarthak have a question like, have we also calculated the percent of hallucination for UT generation?
Yeah, so basically that is why we are using the we are testing it, we are
Mhm.
validating it 5 times, and we are checking whether the coverage has been increased or not. So
Yeah.
that's why we are added that step, so that the hallucination might not happen. Even if it happens, we don't have to include those tests also in the test file. So that's why we included that step. So hallucination, definitely it's going to ChatGPT or AI models going to do hallucination, but we made a step to clear out that. So
Got it. That makes sense. I think that's all for now. Over to you, Akash.
Yeah. So hi there. I'm going to demonstrate how to get the coverage without SDK approach. So let me share my screen first.
Yeah,
So
I
I
think
hope my screen is visible.
yeah, it's visible.
So earlier you have to import the language specific SDK and make a lot of code changes to get the coverage report. But now a simple Keploy test can do the same. So uh, your coverage would get calculated and dumped in report subfolder of Keploy. So there are a few prerequisites for each language that you have to ensure. For Go, it is that your application should have a graceful shutdown to stop the API server. With graceful shutdown, I mean your application is shutting down in an orderly and graceful manner. So this is a small function which you can copy and paste in your application uh, that will demonstrate that will give the functionality of graceful shutdown. And second point is your Go binary must be built with dash covered flag. So taking you to a sample Go application, we have GenMongo here. So in main.go, I've already added graceful shutdown right there. So I will go ahead and build the binary with dash curve flag. So the binary has been built. This is the binary right here. So let's run Keploy test, and this should be able to generate the coverage report. So as you can see, the language detected is Go, and if a different language is generated, you can change it via dash dash language flag. Ignore these errors. These are due to certificate issue, not related to coverage thing. So the test set 0 has ran successfully. Test set 1 has also been ran successfully. So the total coverage came out to be 80.68%. And also we are dumping the coverage in report subfolder. I can show you that. So it has little more information like file coverage. So in our case, handler.go has a file coverage of 75.44% and main.go has 90%. So getting to Python, for Python, you must have Python 3 and above and coverage PY installed. So taking a samples Python application, we have Flask Mongo. So in this, just run Kepler test. As I have NYC already installed in my system, I would just run Kepler test and coverage would get dumped. So the command for my application is npm run start. So JavaScript has been detected as language. So there are some errors. All right. Okay, sorry, this is a Python application. So we need to run Python app.py. So Python language has been detected. So Kepler has calculated coverage and inserted the report. The total coverage comes out to be 61%. Let's check the report. So app.py has a percentage of 64 and joke.py has 40% coverage. So you can also generate an HTML report uh, by using the coverage tool. The command is coverage report, and you have to specify the raw coverage file which gets generated. So in this case, we have .coverage.keploy. So this generates a console-based output, and to generate HTML-based output, you have to use HTML subcommand. So I can open it and show you how it looks. So you can analyze line by line coverage with the help of HTML report. Yeah, that's it for Python. Now going to JavaScript, you must have NYC installed in your system. So, so we would take Express Mongoose as a sample application. Uh, as I've already installed NYC in my system, I would just go ahead and run Keploy test npm run start. So it took a little time to start my application. That's why these errors were coming. So I would just increase the delay. So my application has started. So I think there is some kind of error.
I think we can come back to the one that's throwing an error and maybe debug it at a
Yeah.
later stage and let everyone know what's the issue.
So let me show you how to get the coverage for Java applications. You need to ensure that you have Jacopo installed in your system. Uh, for Maven is it you have to include this dependency. Uh, you can just copy paste in pom.xml. So coming to a samples Java application, we have employee manager. So I would just install all the dependencies if it's not already installed and clean the target folder from already existing raw coverage files. Yeah, so this has ran. So I would run uh, my jar file with java dash jar and the part to the jar file. And I'm setting the delay to 15. So Keploy has detected Java language. So I need to increase the delay. It is taking 20 seconds. So we keep it 25, 26. So the first test has ran. So yeah, the total coverage comes out to be 29.08%. And in this case also, you can analyze the HTML file, which is found in target slash site slash Keploy2 key uh, and get and analyze the line by line coverage. So this is the HTML report. So yeah, that's it for Java. And yeah, I think that's it.
Yep. Thank you, Akash. Thank you, Charan, for showcasing what's new with Kepler. If anyone has any questions, they can ask. As well as I'll share the Slack link in the chat. So if you have any questions, if you try out, have feedback for us. Would love to get started with this thing. Meanwhile, if anyone has any questions, you can share in the chat itself. So that's the URL. That's I think that's very much it. Thank you all for joining in. Thank you, Charan and Akash, for showcasing. And hope you have a great day. Bye, everyone.